Hello guys, and welcome once more to this new video into our YouTube channel. So in today's video we are going to be solving a question on mechanics, more specifically a question on direct impact. So in today's video we are going to be solving a common essay examination. That is, today we are going to be solving a question on pure mathematics with mechanics paper 3 of June 2019. So we are going to be solving the question which came on direct impact in this year. So the question reads: a smooth sphere A of mass 3m moving on a smooth horizontal table with speed 4u impinges directly on another smooth sphere B of mass 2m moving with speed u in the opposite direction to A. The coefficient of restitution between A and B is E. In the A part of the question, we are asked to find in terms of E and U the speed of B after the impact. The next question is being introduced with a paragraph, that is, if immediately after the collision the speed of A is 4u divided by 3, the B part we are asked to show that E, that is the coefficient of restitution, is equals to 1/3. In the C part we are asked to find the impulse exerted on A by the impact. And the next part of the question, that is question D, is being introduced with another paragraph, that is, at the moment of the impact the line of centers of the sphere is perpendicular to a vertical wall which is at a distance x from the point of collision and nearer to B than to A, and B subsequently collides with the wall. In the Z part of the question, we are asked to find in terms of x the distance of A from the wall at the instant when B hits the wall. So we are going to answer this question. We are going to enter the detail to explain how to get the different expressions, how to get the different proofs in this question. Let's not actually look into the solution of this question. So we are being told that we have a smooth sphere A of mass 3m which is moving on a smooth horizontal table with a speed 4u, and this smooth sphere A impinges directly on another smooth sphere B of mass 2m, and this sphere B is moving with a speed u in the opposite direction to sphere A. We are being told that the coefficient of restitution between A and B is E. In the A part we are asked to find in terms of E and U the speed of B after the impact. So since we are solving a question on mechanics, we are going to illustrate a different scenario which we can have. So the first scenario is the one which we have before impact. The second scenario is the one which we have during the impact, where we have the different impulses. And the third scenario is the one which we have after the impact. So since in the question asking us to get the speed of B after the impact, so we are simply going to apply the law of conservation of linear momentum, and we are also going to apply Newton's law of restitution. So from those two laws we are going to obtain a system of equations from which we are going to resolve and get the speed of B after the impact. So applying the law of conservation of linear momentum, which says that what momentum before collision, momentum after collision. Momentum before collision actually equals to 3m times that is momentum before collision is actually equals to what? Masses of the different spheres times the corresponding speeds, that is Tm will correspond to the mass of sphere A times its corresponding speed, which is 4u, then minus 2m times u, where 2m corresponds to the mass of sphere B. And then why have I included this negative? Why this negative? The negative due to the fact that, remember, the speed of sphere B is actually u, but I indicated this negative. Why? Because in the question we are being told that sphere B is moving with a speed u in the opposite direction to A. So after indicating the speed of sphere B before collision, I must include this negative. Why? Because sphere B is moving in the opposite direction to sphere A. Then momentum before collision equals momentum after collision. Momentum after collision is actually what? The corresponding masses of the two spheres times their corresponding speeds after collision. So I indicated VA. That's, let VA be the speed of the sphere A after collision, and let VB be the speed of the sphere B after collision. So further simplifying, we are going to obtain, that is dividing both of the equation by m, we are going to have 12u minus 2u to be equals to 3VA plus 2VB. Now further simplifying again, we get 10u to be equals to 3VA plus 2VB. Let's call this our equation 1. Also, applying Newton's law of restitution, we are going to have VA minus VB divided by UB minus UA, where VA and VB are the corresponding, that's where VA and VB are the speeds of sphere A and sphere B after collision respectively, and UB and UA correspond to the speed of sphere B and sphere A just before collision, to be equal to E, which is the coefficient of restitution. So knowing already UB and UA, we can further simplify and have VA minus VB to be equal to E times negative U minus 4U. Remember, UB is negative U. Why? Because sphere B is moving in an opposite direction. That's the first. B is moving with speed U in the opposite direction to A. This is why I indicated negative U here. Then minus 4U. So further simplifying, we get negative 5UE to be equal to VA minus VB. And let us call this our equation 2. So having these two equations, we can then solve these two equations simultaneously to get the required speed of B after the impact. So having the two equations, that's equation 1 and equation 2, we can simply do equation 1 minus 3 times equation 2. Why? Because doing this, VA is going to cancel. So doing this, I will simply VA is going to cancel. I'm simply going to be left with VB. So doing this, we are going to get 5 VB, that is 2 VB minus 3, because if you multiply that if you do equation 2 times, if you multiply negative 3 in equation 2, obviously we are going to have 5 VB. Why? Here because we are going to have, why? Because here we are going to have 2 VB then plus 3 VB, which give us 5 VB to be equal to 10U, then plus 15 UE. From which, further simplifying, we get VB. That is, we get the speed of sphere B after the impact to be 2U plus 3UE, which is actually the speed of B, which is being expressed in terms of E and U, as been asked in the A part of the question. In the next part of the equation, we are being told that if immediately after the collision, the speed of A, that is the speed of sphere A, is 4U divided by 3, we are asked to show that E is equal to 1/3, that is the coefficient of restitution equals 1/3. So here we are simply going to apply Newton's law of restitution. Why? Because applying Newton's law of restitution, we can easily get that value of E. Why? Because we already have everything on hand. Because in the A part of the question, we obtain the speed of sphere B after impact. In the question introducing the B part, we are given the speed of sphere A after the impact, and obviously we know the initial speed of sphere A and sphere B before impact. So we can simply apply Newton's law of restitution here to get that required expression of E, to get that required value of the coefficient of restitution. So applying Newton's law of restitution, we are going to have VA minus VB divided by UB minus UA to be equal to E. And from which, further simplifying, because we know the value of, we know UB and UA, which are the initials, which are the speed of sphere A and sphere B just before collision. So from which, further simplifying, we get negative 5U to be equal to VA minus VB. But obviously we know VA, which is actually the speed of the sphere A after collision, which is given, that is 4U divided by 3, and VB, which is actually 2U plus 3UE, which we have obtained in the A part. For which, putting those values here, we are going to have what? We are going to have negative 5UE to be equal to 4U divided by 3, which corresponds to VA, then minus 2U, then minus 3UE. For which, further simplifying, we are going to get negative 5UE to be equal to negative 2U divided by 3, that's if you do the LCM here, then minus 3UE. From which, if you further simplify again, we are going to have a negative 2UE to be equal to negative 2U divided by 3. So I simply send negative 3U on the left hand side. So from which we can therefore get the expression for the coefficient of restitution, that is E to be equal to 1/3, which was actually what was being asked for us to prove in the B part of the question. So in the C part, we are asked to find the impulse exerted on sphere A by the impact. So obviously we are going to take our second scenario, which we have, where we have the different impulses. So indicating that second scenario, we are going to have this, where GA is actually the impulse exerted on A by the impact, which we are going to be looking for here actually. So GA, which corresponds to the impulse exerted on A by the impact, actually equals to the mass of sphere A times the difference of its speed, that is final speed of sphere A minus its initial speed, that is the speed of sphere A after collision minus the speed of sphere A before collision. For which further simplifying, we get the impulse dated on A by the impact to be equals to 3m then times VA, which is known to be 4u divided by 3, then minus UA, which is actually 4u. For which further simplifying again, we get the impulse dated on A by the impact to be actually equals to 3m then times negative 8u divided by 3. For which further simplifying again, we get the impulse dated on A by the impact to be negative 8mu actually. Which was actually what was being asked for us to obtain in the C part of the question. So the D part of the question is being introduced with a small paragraph. That is, we are being told that at the moment of the impact, the line of centers of the sphere is perpendicular to a vertical wall, which is at a distance x from the point of collision and nearer to B than to A. And B subsequently collides with the wall. In the D part, we are asked to find in terms of x the distance of A from the wall at the instant when B hits the wall. So let us observe this small figure. That is, I illustrated that scenario with this figure. That is, since the line of centers of the sphere is perpendicular to a vertical wall, it means you must indicate the vertical wall as such, because the vertical wall be indicated as such tell us that automatically the line of centers of the sphere is obviously perpendicular to a vertical wall. Okay, so indicating the vertical wall as such, we are satisfying already the condition which says that what the line of centers of the sphere is perpendicular to that vertical wall in question. And we are being told that this vertical wall is at the distance x from the point of collision. That is, at the distance x from the point of collision. So let D represent the further distance moved by the sphere A immediately after the impact. And obviously, since all the distance is x, and we suppose, or we let A to be the further distance moved by sphere A immediately after the impact, automatically is going to be x minus t. Clearly. Now, what are we actually trying to obtain? We are actually trying, in the equation, they're asking us to get this distance x minus t. Why? Because in the equation, we are asked to find in terms of x the distance of A from the wall at the instant when B hit the wall. So when B hits the wall, automatically sphere A will have traveled a certain distance, which I let a distance to be equal to D here. So in the equation, they're asking us to get this distance x minus t. And you all agree with me that since they're asking us to get that distance in terms of x, the only parameter we are going to be looking for here is actually D. Because having D, we can therefore make the difference, okay, of x minus t automatically. And how therefore can we obtain that distance? And how therefore can we obtain that distance D? Simply, we are going to use the condition. We are going to use the fact that the time taken by sphere B, okay, to reach the wall after the collision is actually equals to the time taken by sphere A to cover this distance D. Okay, so we are going to get that time, that we are going to get the time taken by sphere B to reach the wall, and we are also going to get the time taken by sphere A to cover this distance D, and we are going to equate those two times. Okay, and from which we are going to obtain the expression of D. And once we are going to have D, we are therefore going to be able to obtain this difference, that is x minus D simply. So in the first, we are going to obtain that time, that we are going to obtain TB, which corresponds actually here to the time taken by sphere B to reach the wall, which is actually what? The whole distance, that is, which is actually distance divided by the speed. Okay, to get the time, that is distance here is x divided by the speed, which we have obtained the A part, that is 2u plus 3u, 2u x divided by 2u plus 3ue, from which obviously we already know the value, knowing the value of E, the coefficient of restitution, which we have proved in the B part, which was actually 1/3. We get TB, that is the time taken by sphere B to reach the wall. Doing the similar thing for the time taken by sphere A to cover a distance D. Okay, we get TA, that is the time taken by sphere A to cover a distance D to be equal to that distance D divided by the speed of sphere A immediately after the impact, from which, further simplifying, we get TA to be equal to 3D then divided by 4U. And as I said, the only condition which we can use here is actually the fact that TA equals to TB, that is the time taken by sphere B, okay, to reach the wall immediately after impact is equal to the time taken by sphere A to cover a distance D, as shown on the figure, or as shown on this figure actually. So doing TA equals to B, we get actually x divided by 3u, because we obtain TA and TB. So equating them, we get x divided by 3u to be equal to 3d divided by 4u, from which, further simplifying, we get the expression for d in terms of x, that is d here is going to be equal to 4x divided by 9. And since we have d, we can therefore obtain this difference, which is actually the distance of A from the wall at the instant when B hits the wall. Because at the instant when B hits the wall, this condition enables us to do this, that is to equate this time, because at the instant when B hits the wall, we have this condition which is satisfied, which is valid so far. So having this d, we can therefore obtain the difference x minus d, which correspond automatically to the distance of A from the wall, okay, at the instant when B hits the wall. Because using this condition, we equated TA and TB, and equating TA and TB, we obtain therefore the expression of D. So this expression of D is valid for us to proceed with the solving. So having this D, we can therefore obtain the difference, that is, but we want the distance of A from the wall, that is, we want the distance x minus D, as I said. So having D already in terms of x, we can therefore do the operation of that difference, that is x minus D, which is 4x divided by 9, and which further simplifying, we simply get that distance, that is this difference x minus D, to be actually equals to 5x divided by 9. That is, we do the LCM here, we get 5x divided by 9, which was actually what was being asked for us to obtain in the D part of the question. So thank you very much for watched this video. So don't forget to like, subscribe, and share for the others to benefit from the content. So thank you very much for watching this video, and remain tuned for the very next interesting video. Bye bye.